Machines that are made today are obviously computers, and they will talk to the world, and there's like a whole host of protocols. And the game there, which is certainly important, and there's a lot of great companies doing interesting work to collect machine information, analyze it, and then do very smart things on the abundance of data. And some people like to call that big data. In comparison to that, we're a small data company, right? Because we do collect a lot of data, but this data doesn't come from machines that spit out information all the time. It comes out from people, and it may come from machines that are 20 years old, or something like that, or 15 years old, and they would be sort of obsolete. But hey, they're doing their job, and they're expensive, and they're critical for the manufacturing process, and they're just using technologies from an era ago. How do you get those machines? How do you retrofit them? So with our technology, with our IoT gateways, we can simply connect to their automation equipment, and using the cloud tool environment I described earlier, kind of define the events that would be supported, or that whatever that machine, basically take that machine and bring it to the cloud. Essentially, retrofit an old machine and allow it to talk to the cloud. That's going to be a very important tool to help sort of usher the change. It's not that you're going to completely transform all the machinery in the United States or around the world with new class of machines overnight, because now the internet is important. It's going to be a very gradual process. So yes, I mean, machines are important and all that kind of stuff. But what's more important is that at the end of the day, any machine, $1 million machine or a $1,000 machine, it's really dumb unless some human comes up to it and tells it what to do. And that is usually a repetitive process. It takes time, involves things like preventive maintenance, involves things like all sorts of safety and operation protocols, regulation, things like that. How do you make sure that people are trained and are following procedure while setting up the machines? So some machines can help operators do that, but many of them are just like it's like tribal knowledge and muscle memory. And that's tough, and those machines are complicated. So I think having shop floor apps to do that is also a pretty interesting area for us as well. The nice thing is that our core customer is typically what we call the process engineer. Process engineer is kind of a catch-all term for like the quality assurance engineer, industrial engineer, lean engineer, all the different engineers that come together and create the manufacturing process. So different engineers need different apps. The quality engineer might need quality data collection, and that's typically done either with automated data point collection using various sensors. I mentioned the thermal camera. It could be machine vision systems that check for specific defect, as comparing it visually, like a visual inspection or a CAD inspection, a CAD comparison. It could be specific gauges or other measurement tools. Imagine like a digital caliper that you just use it as a caliper, and it records the data automatically in the system. So with that, those would be like examples of what a quality engineer would use. The process engineers typically create work instructions. Work instruction is like the key document the industry uses to create, step by step. Here's how you do something. They usually end up as wallpaper, and because humans learn and remember, they just avoid using it. The problem is if you follow lean methodology, if you don't use it, you're lowering the chances of you actually finding more value and transforming it to your customer, because lean tells you, and this is the sort of the anomaly of lean, that when you find a way to do something better, you need to change your process. Now, you would agree it's tougher to change wallpaper or static documents. It's easier to change an interactive document that has some sort of a digital thread, so it like knows its versions, and it can we have an easy way to collect comments on the process and to share them around, and we obviously have all the bells and whistles of the internet. So like we have videos and images and a whole whole library of symbols and graphics that you can use. But that's not enough. The biggest thing on the process is like that process engineer should decide things like, well, I don't want the operator to click in any information here. I want it to be collected automatically by the sensor, and just tell the operator, like, now you scan in a barcode and now you put this on the scale, and if the scale hits the right number, then you can actually move it to the packing area. That is a pretty, like, we can speak that, and it's well understood because that's how humans think. We kind of think in constructs that if first you do this, and if this happens, you do that, kind of like a flowchart. But if you want to codify it, like, they're basically like, your option is like hire a programmer, a developer, or your engineer train somebody, the human, to be the computer and make those decisions, or we build those apps that I'm telling you about that could guide someone and encode this behavior, and that's basically the crux of interactive work instructions that would guide someone through the process.